Hello, everybody. My name is Paul Cercueil. I work for Analog Devices. I'm a software engineer, and today I'm going to present you Liblio version 1. So before I can talk about Liblio, I need to talk about I/O. I/O stands for Industrial Input-Output Framework, and basically it's the subsystem of the Linux kernel in which you will find all the input-output devices that we couldn't fit somewhere else. So everything that doesn't fit into the hardware monitoring or audio input subsystems goes to the input-output framework. Libiio was the project I started when I joined ADI in 2014. Since then, it's seen 56 different contributors as of today. The latest version is version 0.34, and that will be hopefully the last version 0.x, because we are shifting the development to a new improved 1.x version. The goals of the library is to allow your application to interface with the I/O subsystem of the Linux kernel, abstract away all the low-level details of the interface, and give your application high-level representation of all the I/O objects and concepts. It's written in portable C99s, modular, thread-safe, runs on Linux, Windows, etc. It's LGPL as well. Libiio has the concept of backend, so your application uses the high-level API, and then you have backends, for instance, the local backend to talk directly to I/O devices connected, I/O devices like local with the kernel, talking directly to the kernel. You have backends, for instance, to talk over the network to IOD server instance running on the board, for instance. You have a backend to talk over USB, over UART. And all of this is transparent to the application. The API is the exact same. So one application, you can even compile it and interchange the backends. If you design your application to run with over the network, and then you can run it over USB, it totally works. It also allows us to run applications on non-Linux systems. So let's take Pluto, for instance. Pluto SDR has a Libiio stack with the IOD server. And we can develop applications on Windows talking to the Pluto SDR this way. So why the need for a new version? Well, in 8 years of existence, Libiio never actually broke the API or ABI, which means that the sources written and the binaries compiled back in 2014 for Libiio version 0.1 still run fine today with the version 0.24. It also means that crust accumulated over the years. There's some cleanups to do. But more importantly, some changes were just impossible to implement without breaking everything. Hence the need for library version 2, and by version 2 I mean version 1, because the version 1 was actually version 0. Libiio version 1 is developed in the dev branch in the repository. There is no estimated time for the release. It's ready when it's ready. The API right now is pretty much stable, has been pretty stable for months. But it's not fixed in stone, so if we need to change something, we won't hesitate to remove functions or something like that. The major changes include support for multi-buffer hardware. It has a new low-level samples transfer mechanism. It has modular backends. It has a new asynchronous protocol between Libiio and the IOD server. And there's a new interface between the user space and kernel space. Modular backends is interesting for, notably for distributions. If you compile Libiio for Debian, for instance, then you're going to have lots of dependencies that you may not be interested into. So now with Libiio version 1, all the backends can be dynamically loaded. They are installed at their own shared libraries. And you could, for instance, just install the backends that you're interested into. It also means that third-party backends can be written. There is a backends API that you can use and to create your own backend. All the backends in Libiio, the network backend, the USB backend, UART, etc., they only use exclusively the backends API and the regular application API. So they don't try to tamper with internal functions and structures. A bit about data streaming. So the old version 0 Libiio API, the data streaming API was a bit too high level. It didn't give much control to the applications. And as such, it was just impossible to support some use cases like multi-buffer devices. So if you are familiar with Libiio, the IO buffer object does not stream data anymore. The IO buffer refill, IO buffer push functions are gone. And IO buffer now is just takes an index of the hardware buffer that you're interested to for the multi-buffer devices, and the data transfer is handled by something else. The data transfer is actually handled by IO block objects. So the concept of a block or IO block in Libiio is basically it represents a chunk of samples in the system memory. So your application is now responsible for allocating and managing its own IO block objects. And the block can be in two states, dequeued or unqueued. Dequeued means your application owns the block and can read, write the data. And unqueued means it's owned by Libiio or the kernel, and then you should not manipulate it until it's dequeued again. So the process for streaming data, you enable the channels that you're interested in using IO channel enable. You create an IO buffer like before. You create a pool of blocks, the number that you want, specifying the size of each block. If you're transmitting, then you fill them with data. You just enqueue them, so you give them to Libiio and the kernel. You then enable the buffer to start the streaming process. And then in a loop, you can dequeue and block, read the data or write the data, enqueue it back, and in a loop like that. So if you think that this is a complicated API, there is a simpler one, which is higher level. It's IO stream object. It basically just gives you basically have two functions. IO buffer create stream to create the IO stream object. And IO stream get next block, which will always return the next dequeued block to which you can write samples or read samples from, and again, call the function to get the next dequeued block, etc. It's actually implemented on top of the low-level interface, so you could totally do that with the low-level interface as well. The major change, though, with Libiio version 1 is the asynchronous protocol between the IOD server and Libiio in the version 0.24 and older. The protocol was synchronous and ASCII-based. So ASCII-based means that there was quite a lot of data that was transferred that was not samples, just command names and things like that. And it was also complex because it required a semantic parser. It was also synchronous, which means that you couldn't send a new command to the IID server before reading the response of the previous command. So at any time, any moment in a full duplex link, like a network cable or USB, you only had one transfer direction busy at the same time. So either you were sending a command or reading a response, but never at the same time. So that's something that changed in the Libiio version 1 with help of worker threads. So now your IOD client, for instance, the network backend of the library is going to register a command to the worker, get an ID that it can use to identify the response. And that allows transfer to go both ways. If we focus just on the local backend and the interface between the user space and kernel space, the interface that is upstream in the Linux kernel is pretty slow. It's based on file descriptors that you read and write. And reading and writing file descriptors means copying data with the CPU, so it's pretty slow. So I was working on a new interface using DMABUF objects, which is basically a buffer object in the Linux kernel. And instead of copying data, you just get a handle of these buffers, so there's no copy. And it also opens some gates. For instance, we could, for instance, get a DMABUF object from a receiver and queue it to a transmitter without copying the data. And it can go ever further because you could dequeue one DMABUF from an I/O receiver, from an I/O device, and queue it to the network stack or the USB stack and get the data sent over the network or USB without copying the data again. It was refused upstream, sadly. It's still working on it, and hopefully it can be merged sometime. A bit about compatibility. So if we consider the communication between Libiio and the IIoD server, basically now everybody can talk to everybody, so version 0 to version 1, version 1 to version 0, and obviously version 1 to version 1. There's also a compatibility layer that is a separate library. It replaces the old library and allows to run old application compiled with Libiio version 0 on top of Libiio version 1 and get the benefits of the new library. A quick slide, something we've been working on is the timestamp API. It's not implemented yet. Basically, it would allow to schedule transfers. For instance, we could say, let's transfer this block of samples in exactly 300 cycles from now. It will also allow to detect from the application underruns and overruns, because right now with Libiio, that's not something that can be done. A bit about performance. So I did some tests with Z-board with gigabit Ethernet and AD9361 and 32K samples blocks. With the old library, I was getting over the network 43 megabytes per second. With the new library, 64 megabytes per second. So that's a good 50% increase, thanks to the asynchronous protocol. And then I did the same experience with the Pluto SDR. And as you can see, the speed is the exact same, 24 megabytes per second. The reason for that is the Pluto SDR is bottlenecked by the CPU and not by the USB link. So yeah, the asynchronous protocol just helps a lot when the link is the bottleneck. So yeah, all my talk was about Libiio version 1, but why should you care? Well, the whole stack below GRIIO, if you guys use GRIIO, is Libiio, be it on the GNU Radio side to talk to the board, and also on the board in the firmware. So GRIIO will have to be updated when Libiio version 1 is released to add support for the new shiny stuff like multi-buffer I/O devices, to reduce the overhead thanks to the asynchronous protocol. And that's about it, because the blocks are not going to change that much. They will still be pretty much the same. In the meantime, the GRIIO blocks will just work fine with the compatibility layer. So even when Libiio version 1 comes, GRIIO can still work fine with the compatibility layer. So there's no rush to update it. And thank you for listening. If you have any questions, we'll be happy to answer.
So, all right, there's a question over there.
Thanks. I got a question regarding the timestamp support. So you mentioned it specifically for the 1.0 branch. Are there any plans to also add it for the 0.2 branch?
No, so the version 0 branch is basically dead now. We only merge bug fixes, and all the development is done on the dev branch. Yeah.
Okay, that's clear. Thanks.